Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions.
This particular paper is EdExcel June 2023, Paper 1, Higher Tier.
Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it.
Question 1. Work out 8.46 divided by 0.15. Okay, so when you're doing division and it's involving decimals, I find it easier just to get rid of the decimal straight away. And you can do that by multiplying both numbers by 100 in this case, or a power of 10. So if I times 8.46 by 100, I'm going to get 846. And if I multiply 0.15 by 100, I'm going to get 15, aren't I? So I'm going to end up with 846 divided by 15. So then 15s into 846, 15s into 8 don't go, 15s into 84 go 5 times. Remainder, well 5 15s are 74, isn't it? So that's going to be remainder 9. So 15 goes into 96 6 times. Remainder 6 then, doesn't it? So I'm going to have to add in an extra 0 to my number to attach that remainder to. And then I'm going to go again. 15s into 60, that goes 4 times, isn't it? So my answer is going to be 56.4. Question 2, work out 7 3/8 minus 2.5. Okay, so I've got two mixed numbers that I'm subtracting. Now, in order to do the subtraction, probably the easiest thing to do is to rewrite both of those as improper fractions first. So 7 3/8 as an improper fraction. 7 times 8 is 56. Add on the 3 is 59. So 7 3/8 is the same thing as 59/8. Minus 2 times 2 is 4. Add on the 1 is 5. So 2.5 is 5 halves. Okay, so now I've got them both as improper fractions. I'm just going to do what I normally do with subtraction, which is to find a common denominator. So I can do that pretty easily just by multiplying top and bottom of that second fraction by 4. Then it's going to give me a fraction over 8, isn't it? So that's going to be 59 over 8 minus 5 4s are 20 over 2 4s are 8. So I've got 59/8 minus 28, which 59 minus 20, that's going to be 39/8. And then just to put it back into a mixed number, how many times does 8 fit into 39? It goes in 4 times, isn't it? Because 4 8s are 32, remainder 7. So that's going to be 4 7/8 is my final answer then, 4 7/8. Question 3, a cube has a total surface area of 150 centimeters squared. Work out the volume of the cube. Okay, so if you've got a cube, it's got 6 faces, isn't it? Okay, and then each face is going to be of length L. Let's say that's the length and width of the cube. So each face is going to be L squared, then, isn't it? The length times itself. And if you've got 6 faces on the cube, then the total surface area should be 6L squared, where L is the length of the cube. Okay, now I know that that's equal to 150. So if I do 6's, well, divide both sides by 6, I should find that L squared is equal to 6's into 150 goes 25 times. So L squared is 25, and then square root in both sides, I'm going to get L is the square root of 25, it's going to be 5. Now remember, we needed to work out the volume of the cube. So if I know that the side is 5, then the volume is going to be L cubed, or 5 cubed, which is 125, isn't it? So that's my final answer, 125. Question 4. The table shows information about the daily rainfall in a town for 60 days. And we can see the rainfall varies each day from between 0 to 5 up to between 20 and 25. Okay, and we need to draw a frequency polygon. Now, with the frequency polygon, you draw a cross in the center of each bar at that frequency. So in the 0 to 5 bar, the midpoint of that bar is going to be halfway between 0 and 5, which is 2.5. You can just add the two numbers together and divide by 2 if you can't see it. But yeah, that's 2.5. The middle of the next bar is 7.5. The middle of the next bar is going to be 12.5. The middle of the next bar is going to be 17.5, and then the middle of the next bar is going to be 22.5. So that's where I'm going to plot my crosses. So I'm going to put at a height of 8 and at 2.5 my first cross like that. The next one is going to go at 7.5 at a height of 24, which is here. My next one is going to go at 12.5 at a height of 13. Then we've got 17.5 with a height of 11. And then finally we've got 22.5 with a height of 4. Okay, so then once you've finished drawing all your crosses, you're going to just join them up with a series of straight lines. Okay. So we don't draw curves with this one, just straight lines between each one of those points. Clues in the name, it's a polygon, frequency polygon, although it doesn't join back to itself because polygons normally enclose space. And I suppose technically if you wanted to call it a polygon, you'd have to join the first point with the last point, and we don't actually do that, so I'm not quite sure why it is actually called a polygon. Okay, frequency polygon. Question 5. I've got a set E which contains the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A is the set of odd numbers. B is the set of square numbers. Complete the Venn diagram for this information. Well, the odd numbers in this set then, remember only including the ones in the universal set which have been given there. So the odd numbers in there are going to be 1, 3, 5, 7, 9. And then the square numbers are going to be 1, 4, and 9. Okay, so a couple of those were in both, weren't they? So 1 and 9 were in both the odd numbers and the square numbers, so they're going to go in the middle. So 1 and 9 go in there. Then we had 4, which was a square number but not an odd number, and we've got the numbers 3, 5 and 7, which are odd numbers but not square numbers. Plus we got a few bonus ones, haven't we? We've got like the 2 and the 6 and the 10, which aren't in any of those groups, so they go on the outside. They're going to go 2, 6 and 10. Okay, now when I'm drawing Venn diagrams, I don't know if you notice, but when you're actually putting the actual values into them rather than the number of things in here, because like in some Venn diagrams you just put like the number of elements, so let's look at 3 in that one, 2 in that one, 1 in that one, and 3 in that one. So distinguish between what you're doing. If you're actually putting the actual elements in, we draw them with a dot next to them. That's what you meant to do, although you won't get marked down at GCSE for not doing it. I just do it that way because that's the proper way of doing it. And then if you're going to say how many elements there are in there, so rather than write in the actual elements themselves, you write that there are 3 of them, then you do it without the dot. That's kind of the distinguishing feature of those. Okay, right, so yeah, so that's that. So then a number is chosen at random from the universal set E. Find the probability that the number is in the set B complement. So that little dash next to B means everything outside B. Okay, so if I was looking at everything outside B, then it would include all of those down there and those up there, wouldn't it? Everything outside B. So it's going to be the 3, the 5, the 7, the 2, the 6, and the 10. They're all the values outside B. Oh, I just realized I missed off an 8, so I should really put that one back in as well. Oops. Should be an 8 there too. So that means there are 7 values outside of B. So as a probability, then that's going to be 7 over 10 then, isn't it? Okay. Always a good idea to check you've got the right number of things in your Venn diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, match. Question 6. The scatter graph shows information about the ages and weights of some babies. So we've got ages along the bottom from 0 to 12 months and weight up the side from 0 to 12 kg. Part A says describe the relationship between the age and the weights of the baby. Okay, now notice it's saying the relationship and not the correlation. So I'm going to say that as the age of the babies increases, the weight also increases. Okay, so they're not asking you to describe correlation, positive correlation, negative correlation. They want the relationship between them. As one goes up, what does the other one do? Okay, another baby has a weight of 5.8 kg. Use the scatter graph to find an estimate for the age of this baby. Okay, so in order to do an estimate, the first thing we need to do is to draw a line of best fit. Okay, so if I kind of angle my ruler, can you see, you know, if I just try and put the ruler like so it captures as many of those points as possible, it's going to be something like that, isn't it? So then my line of best fit is going to be in the middle of the ruler. I think that's quite a good way to do it. If you've got like your a clear ruler, and it's quite a handy way. So then just dropping halfway between, that's where my line of best fit is going to go. So no, it's not an exact science, this, and if yours is slightly different from your neighbours, it's not the end of the world. Okay, you know, you get marked on yours from your diagram. Okay, so there's my line of best fit. I use the scatter diagram to find an estimate of the age of this baby, who is 5.8 kilograms. So I'm going to find 5.8 kilograms on the scale. So here's 4, here's 6, 5's in the middle. So each one of those little tiny squares is 0.2. So I need to come down one little square under 6 for 5.8, don't I? So I'm going to be drawing across from there. It's a good idea to show method by actually drawing on your graph like this. Okay, and then I'm going to change directions and draw a line going down. Okay, so it's a little bit over 3, isn't it? It's like 3.2 months. Okay, so I'm going to write 3.2 months. Question 7. The price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. Okay, well, if 20% of my amount is 240, then 100%, which is what it would be at the beginning, is that amount times 5, isn't it? So if I times it up by 5, then I'm going to get £1,200. Okay, so that is the amount of money before the increase then, wasn't it? So 1200. Question 8. The diagram shows a solid cylinder on a horizontal floor. The cylinder has a volume of 1200 cubic centimeters and a height of 40 centimeters. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor due to the cylinder. Okay. So we got a formula for pressure. We got pressure equals force divided by area. Now we know the force. Force is 90 newtons. Okay. So pressure equals force equals area equals. We know what the force is. The force is 90 newtons. So we got that part of the puzzle. Okay, do we know the pressure? No, that's what we're trying to find, isn't it? We're trying to work out what the pressure is, and that's going to be our answer. So that's the one we're going to find. Do we know the area? Well, we can probably work it out, can't we? We don't know it yet, but we can probably do it from the diagram. So what is the area? We need to work out this area down here. Now we know that the volume inside this shape is equal to what is it? It's 1200 cubic centimeters, isn't it? So that's equal to 1200 cubic centimeters. Okay, but we also know that volume is given because this shape is a cylinder. It's essentially a prism, which is the area of the cross section times its height, isn't it? So this is going to be the cross sectional area times the height, and so we know what the height is already. So we know that A times H equals 1200, and we know that H is 40, so that means 40A equals 1200. So what is the area of the base then? It's going to be 1200 divided by 40. So 1200 divided by 40 is the same thing as 120 divided by 4. It's going to be 30, isn't it? So this has an area of 30 centimeters squared. So that's going to be my 30 over here in this calculation. So pressure equals force over area, which is 90 over 30. That gives me an answer of 3 what? Newtons per centimeters squared. Oh, I gave the unit down there, so I didn't have to work it out. But anyway, that was fun. So 3 newtons. Question 9. Use the graphs to solve the simultaneous equations 2 minus 2y equals x and 2y equals 3x minus 22. Now this looks highly complicated, these very tricky looking simultaneous equations, but like that one there is essentially this one, isn't it? It's this line. This is the line. 2 minus 2y is equal to x. So the point we're looking for is somewhere along that line. Okay, but then this line here, look, that's this one here. So it's this line is the other one. So our solution is someone on that line as well. So if it's on the green line and it's also on the yellow line, then the only point that's on both is that point there, isn't it? So that is the solution we're looking for. We just need to work out what that coordinate is. So you can see the x coordinate is 1 unit to the right of 5. It's going to be 6, and the y coordinate is what, -2. There we go, so it's 6, -2. That wasn't hard. Question 10. Here is a pentagon. Angle AED is 4 times angle ABC. Work out the size of angle AED. You must show all of your working. Where's angle AED? AED. AED. It's that angle there then. That's the one there. So that angle there is 4 times angle ABC. Where's angle ABC? ABC, that angle there. So if I know that the yellow angle is 4 times the green one, but I don't know what the green one is, great time to use a little bit of algebra. Let's call that unknown angle there x. So if that angle there ABC is x, then AED, which is 4 times as big, must be 4x. Okay, so now I've got something down for each of the angles. I also know what the name of this shape is. It's a pentagon, and I know what the sum of the interior angles of a pentagon are. So the sum of the interior angles of any polygon, so sum interior angles, that's equal to n minus 2, the number of sides minus 2 times 180. It's essentially the number of triangles inside your shape. So if you've got n sides, then you've got n minus 2 triangles inside it. So if I've got like 1, 2, 3, 4, 5, a pentagon, then you can take a pentagon and divide it up into 1, 2, 3 triangles. Okay, so n minus 2 in this case is 3 then, isn't it? It's 3 times 180 because there are 3 triangles inside a pentagon. So 3 lots of 180 is 540. So I know that all the angles should add up to 540. Okay, so then I can form an equation in X here and then hopefully go on to solve it. So adding up all the angles, I've got A, which is 100, plus B, which is X, plus C, which is 110, plus D, which is 135, plus E, which is 4X. And I know that all of those added together is equal to 540 because that's all the angles inside the pentagon. So collecting like terms together, I've got a term in X there and there. So that gives me 5x altogether, 5x, plus I've got 120, 110, 135. That adds up to 230, 330, 365. So plus 365, and that's equal to 540. So then taking 365 away from both sides, going to cancel there, leaving me with 5x on the left. On the right, 540 minus 365, what's that then? 0 take away 5, we'll borrow 1. 10 take away 5 is 5. 13 take away 6 is 7. That's 175 then, isn't it? So 5x is 175. So x is going to be a fifth of that. What's that? That's going to be 35. So x is 35. So what's the question? Work out the size of an angle AED. Okay, so x is 35 is this one, that one's 35. But AED is this yellow one up here, isn't it? And that's 4x, so that's going to be 4 lots of 35. So that's going to be, what, 140? So that's my answer then, it's going to be 140 degrees. Question 11, write that rather horrendous looking algebraic fraction in the form of ax to the power b times y to the power c, where a, b and c are integers. Okay. So let's have a look at the top line there. You've got a bunch of factors, 6, x to the power 5, y cubed, all times together, and we're raising that to the power of 2. So we got what we call an index of a bunch of indices inside the bracket. Now, powers are distributive over multiplication. So that means that we're going to distribute that square to each of the factors inside the bracket. So it's going to be equal to 6 squared times x to the power 5 squared, that's x to the power 10, multiplying 5 by 2, and y cubed times 2 is y to the 6, okay, and that's over 3 times 4, that's 12, x squared times x is x cubed, and y to the power 7 times y to the power minus 3 is y to the power 4. Okay, so 6 squared is 36. 36 divided by 12, just dividing 12 into 36, that's going to give me 3, isn't it? And x to the power 3 divided into x to the 10, that's going to cancel with 3 of those, leaving you with x to the 7. And y to the 4 cancelled into y to the power 6 is going to leave you with y squared, isn't it? So the final answer then is 3 x to the 7, y to the 2. Okay, so that's in the form a, which is 3, times x to the power b, which is 7, times y to the power c, which is 2. So it's in the right format. So let's just write down our answer, 3x to the 7, y squared. Question 12. Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. Okay, so the first game, she's got a 5 chance in 8 of winning and a 3 chance of 8 in losing. If she wins or if she loses, she's got the same probability in the second game. That's 2/9 and 7/9. Okay, so find the probability that Martha will lose at least one game. Now, losing at least one game is win followed by lose. That's losing at least one game. Or it's lose win. That's losing at least one game. Or it's lose lose, isn't it? Because that's at least one game, losing two games. So we've got two choices here. We can either work out each of those probabilities for win lose, lose win, and lose lose, work them all out and add them up, or the somewhat smarter way of doing it would be saying, well, that's everything other than that route through. So win-win, if we can work out the probability of win-win, then if we take that away from one, then we'll get all the other probability branches added together. So that's going to be the slightly quicker way of doing it. Okay, so me being essentially a little bit lazy, that's the way I'm going to do it. So probability of win-win is going to be the probability of, well, 5/8 times 2/9. What's that then? 5 times 2 is 10. 8 times 9 is 72. Okay, so 10/72 is the probability of winning both matches. So then the probability at least one loss is going to be 1 minus the probability of win-win. Okay, so it's going to be 1 minus 10 over 72, which is, well, 72 over 72 minus 10 over 72 is 62 over 72. Okay, so that's my answer, 62 over 72. So that's a lot quicker than doing all the other three options and then adding them up. Okay, question 13, y is directly proportional to x. Y is equal to 24 when x is 1.5. Work out the value of y when x is equal to 5. Okay, so these sort of questions, they are normally given in three parts. They give you the relationship. That can give you a way of forming or partially forming the equation. They give you a pair of values that go together. That will help you complete the equation. Once you have the complete equation, then you can go on and do this part here. Okay, so there are three distinct stages to these types of questions. So we're going to start off with the first bit. Y is directly proportional to x. Y is directly proportional to x. That's how we'd write it down. Y equal fishy, x, that little fishy symbol, is the symbol of proportionality. Y is proportional to x. Now, that can be rewritten as an equation. Y is equal to kx, where k is the constant of proportionality, which you can then go and find. Okay, so the yellow bit gives us this part. This is the part we get from the yellow bit. So we're done with that. Now we're going to move on to the green bit. We've got a pair of values that go together. So when y equals 24, x is equal to 1.5. So we can sub those two numbers in, and then the only thing we won't know there is x. So y, 24, is equal to k lots of x, which is 1.5. Okay, so subbing those two values in. So if I then divide both sides by 1.5, is that easy to do? Probably if I rewrite k, 1.5 is 3 over 2. That might be easy, mightn't it? 3 over 2. And then so if I want to cross that over to the other side, I want to times by 2 and divide by 3. So 24 divided by 3 is 8 times 2 is 16. So 16 is equal to k then, isn't it? Okay, so now I've got k, I can then complete my equation. So then y is not kx, y is equal to 16x. Okay, so all of this bit here comes from the green part that I've been given. Okay, so that gives us the complete equation. Once I've got the complete equation, I can move on to the last part of the problem, which is to work out the value of y when x is equal to 5. Okay, so when x is equal to 5, then y is going to be 16 lots of 5 then, isn't it? Just sub in the x value in for x. So then y is equal to 16 times 5, that's 80. Okay, so then this bit comes from the final value after we've completed the equation. We found the equation. That gives us the answer of y is equal to 80. Okay. Now, usually when students don't know this method, they get too hung up on the second and third part of the question, and they don't do these things in the right order. So you just need to go through it step by step. Work out the partial equation. Use your pair of values to complete the equation, then go on to use your equation to find the value of y when x is 5. Okay. Question 14a. Write 1 over 16 in the form 4 to the power of n, where n is an integer. Okay. So I've got 1 over 16. Now I know 16 is 4 squared, so I could say that's the same thing as 1 over 4 squared. Okay. But that isn't in the form 4 to the power of something. But I can rewrite that as 4 to the minus 2n, because a negative index means 1 over the positive version of that index. So that's going to be 4 to the minus 2. Okay? And then the second part of the question says work out the value of 8 to the power of 5 over 3 minus 9 to the power of 3 over 2. Okay. So 8 to the power of 5 over 3 means the cube root of 8 raised to the power of 5 minus the square root of 9 raised to the power of 3. Okay? So these denominator parts are here and the square root here. I don't write the 2 down, but that's where they go. And then the numerator parts are the powers that go on the outside of the bracket. Okay, now in this case it's much easier to do the cube root in first. The cube root of 8 is 2, so that's going to be 2 to the power 5 minus square root of 9 is 3 to the power 3. Okay, 2 to the power 5 is 2, 4, 8, 16, 32, just multiplying up by 2 each time, and 3 cubed, 3 times 3 is 9 times 3 is 27, so 32 minus 27, that ends up being 5, and that's my final answer then, 5. Question 15, the equation of the line L1 is y is equal to 2x minus 5. The equation of line L2 is 6y plus kx minus 12 is equal to 0. L1 is perpendicular to L2. Find the value of k. You must show all your workings. Okay, so if the two lines are perpendicular, then the gradient of one is the negative reciprocal of the other. Okay, well, finding the gradient of L1 is super simple. It's just that 2 there, isn't it? Because linear equations in the form y equals mx plus c, it's that coefficient of x that tells you the gradient. So in this case, in L1, then m1, the gradient of L1 is going to be 2. Okay? So, and because the negative reciprocal of m1 is going to give you m2, it's going to give you the gradient of the other line. So in L2, then m2 is going to be minus 1 over m1. It's going to be minus 1/2 then, isn't it? So the gradient of the second line is minus 1/2, but what's going on here, this is all a little bit complicated what we've got going on over here. It doesn't look like it's in the form y equals mx plus c, so I can't just plug that number in. But I can probably make it look like y equals mx plus c. Let's take the equation 6y plus kx minus 12 equals 0 and rearrange it a little bit so it is in the form of y equals mx plus c. First off, let's move that 12 over by adding 12 to both sides. That's going to give me 6y plus kx equals 12. Then subtracting kx from both sides, they'll cancel, and that's going to leave me with 6y equals minus kx plus 12. And then if we divide both sides by 6, so if I divide this by 6, divide this by 6, divide this by 6, they'll cancel. That'll leave me with y. Then I've got minus k over 6x, and then plus 2 then, haven't I? Okay, on the end. So this thing here, this expression that I've got here, minus k over 6, that must be the same thing as my gradient m2 then, isn't it? That's the gradient. So I can say then that minus k over 6 is equal to minus 1/2. Right? So just multiplying everything through by -1, just make it positive. It's going to give me k over 6 equals 1/2. And then times in through by 6 as well. I'm going to get k equals 6 over 2, which is the same thing as 3. Okay, so k is equal to 3. Question 16, here is a sphere, and we've been given the formula for the surface area of a sphere is equal to 4 pi r squared. Then underneath it says 3/8 of the surface area of the sphere is 75 pi centimeters squared. Find the diameter of the sphere. Give your answer in the form of, so the root symbol is missing. Give your answer in the form a root b, where a is an integer and b is a prime number. Okay, this is interesting. Right, so we know the surface area of the sphere is 4 pi r squared, and we know that 3/8 of that is 75. Okay, so if 3/8 of the surface area of the sphere is 75 pi, then the whole surface area is going to be 75 pi times 8 over 3 then, isn't it? Just flipping that over. Okay, so if you take your surface area, you times it by 3/8, you get 75 pi. Then if you divide by 3/8 or times by 8/3, then you're going to get back to your original value then, aren't you? Okay, so then 3's go into 75 25 times. So I'm going to get 25 times 8. 25 times 8 is 200. So the total surface area is going to be 200 then. Okay, so the total surface area of the sphere is 200 centimeters squared then. Okay, so now we know what the total surface area is. Then find the diameter of the sphere. So if that is the surface area, then if I want the diameter, first I need to find the radius, because the formula for the surface area of the sphere is in terms of r. So if I got 4 pi r squared equals 200 pi, so I can see straight away I can get rid of those pi's, they're going to cancel. So r squared is going to be 200 divided by 4, it's going to be 50, isn't it? So r squared is equal to 50. So r squared is 50. So then r is going to be the square root of 50 then, isn't it? Okay. Now the square root of 50 can be rewritten. Well, 50 is 2 times 25. So the root of 2 is root 2 and the root of 25 is 5. So that's the same thing as 5 root 2. So if the radius is 5 root 2, then the diameter is going to be 2 lots of 5 root 2, which is going to be 10 root 2 then, isn't it? Okay. So is that right? A is an integer. Yeah, so my a value, look here, is this one. It's 10. That is an integer. That's fine. And b, the root b part, is b a prime number? Yes, it's a 2 there, isn't it? So it's 10 root 2. 2 is prime. So that's my answer. Fits the criteria. Let's write it down, 10 root 2. Question 17, make x the subject of the formula. So I've got a formula in terms of y, and I need to rearrange it in terms of x. Now spot that there's an x down there and there's an x up here. So when you've got your more than one of the things that you're trying to collect together, I want to make x a subject, I need to collect them together first. Okay, I need to get all those x's and make them one lot of x. So how am I going to do that? First off, I'm just going to cross multiply, moving this part of the expression up here by multiplying both sides by 5x plus 3. That's going to give me y lots of 5x plus 3 is equal to 4 lots of 2x minus 7. Okay, now multiplying out both sets of brackets, that's going to give me 5xy plus 3y is equal to 8x minus 4 7s are 28, aren't they? Minus 28. Okay, right, so now I've kind of got rid of all the brackets and things. I want to get all the terms in x on the left and everything that hasn't got an x in it on the right. Okay, so I'm going to move the 8x over to the left and the 3y over to the right, I guess. Yeah, I might do it the other way around, because then it'll keep more things positive if I do it the other way around. So I'm going to leave the 8x where it is. I'm going to move the 5xy over to the other side, so it's going to become negative 5xy. I'm going to leave the 3y where it is, and I'm going to move the 28 over to join it, so that's plus 28. Okay, just decided to do it that way because it meant less minus signs. Right, now notice I've got an x in here and an x in here, so the next step is to turn two x's into one x by factorizing it out of both those terms. So I'm going to take x out and put a pair of brackets in instead. So that's going to be 8 minus 5y inside the bracket. And then finally, I just need to divide both sides then by that bracket, and I'm going to get my final answer. And I'm going to get x equals 3y plus 28 divided by 8 minus 5y. Okay, so then there's my expression in terms of x. I'm just going to flip it round so x is at the front for my final writing of it down. So x equals 3y plus 28 over 8 minus 5y. Question 18. 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of 480 pence. The cost of 1 kilograms of carrots to the cost of 1 kilogram of tomatoes is in the ratio of 5 to 9. Work out the cost of 1 kilogram of carrots and the cost of 1 kilograms of tomatoes. Now I guess the problem is here that we've got like seven lots of carrots and 5 lots of tomatoes costing £4.80. We know the ratio of the costs of the carrots and the tomatoes, but it's not really easy to apply the two things together. I think what I'm going to do is I'm going to find the cost of one thing. So if I let C be the cost of the carrots and T be the cost of the tomatoes, then if they're in the ratio of 5 to 9, that means that 9 lots of the carrots is going to be equal to 5 lots of the tomatoes. Okay, so yeah, it's just the way it is. When you form an equation in these things, the numbers end up on the opposite sides, and when you've got them as a ratio. So 9 lots of the carrots is going to be equal to 5 lots of the tomatoes. Okay, so if I've got 7 lots of the carrots plus 5 lots of the tomatoes cost 480 pence, I know then that those 5 lots of the tomatoes is the same as that lot, and that's equal to 9 lots of the carrots. So that tells me that 7 lots of the carrots plus 5 lots of the tomatoes, which I know is the same thing as 9 lots of the carrots, is going to be equal to 480 pence. Okay, does that make sense? I've got like that bit there, the 7 lots of the carrots plus the tomatoes, 5 lots of the tomatoes, which I know is the same thing as 9 lots of the carrots, and that is equal to 480, which is what I got from there. Look. All right, so that means that 7 carrots plus 9 carrots is 16 carrots. So 16 kilos of the carrots cost 480 pence. So then dividing both sides by 16, 16's into 480 goes, well, 16 to 48 goes 3 times, so it's going to go in 30 times then, isn't it? So that means the carrots are going to cost 30p each. Okay, and then once I know what the cost of the carrots are, I should be able to work out what the costs of the tomatoes are. So if I know that 9c equals 5t, then 5 lots of t, 5 lots of the cost of the carrots is going to be 9 lots of 30 pence. So 9 30s is 270 pence, isn't it? So 5 lots of tomatoes is 270 pence. Dividing both sides by 5, I'm going to get t is equal to, what's that, 54? Yeah, so then tomatoes are going to cost 54 pence each. Okay? Now, if you've got a little bit of time, it's probably a good idea just to double check by subbing everything back into one of the original equations. So we used the ratio, didn't we, to generate t from c. So if we sub it back into the other one, 7 lots of the carrot, 7 lots of 30, plus 5 lots of 54, is that equal to 480? Well, 7 30s is 210. 5 54s, what's that? That's going to be 5 50s is 250, 5 4s is 20, is 270. Add them together, you're going to get 480. So that does indeed look correct. Okay, good. Question 19. The menu in a restaurant has starters, main courses, and desserts. There are 5 starters, there are 12 main courses, and there are X desserts. There are 420 different ways to choose 1 starter, 1 main, and 1 dessert. Work out the value of X. Okay. So you've got 5 choices for our starters, so 5. And then for each of those 5 starters, you've got 12 choices for mains. That takes you up to about 60 choices. And then you've got X choices for desserts. And if you multiply those 3 things together, you should end with 420, because that's what it tells us in the question. There are 420 different ways. Okay, so 5 12s are 60, so we know then that 60 lots of X is going to be 420. So then X then is going to be 420 divided by 60. So 42 divided by 6, X is 7, so there must be 7 types of dessert. Question 20. For x greater than or equal to 0, the functions f and g are such that f of x is equal to 3x plus 4 and g of x equals root x plus 2 all over 5. First off, we need to find g to the minus 1 of x, which is the inverse function of x. Okay. Now, to work out an inverse function, the easiest way to do it is to just first let y be equal to your original function. So y equals root x plus 2 over 5. Next step is to try and rearrange it and make x the subject. So multiplying both sides by 5, I'm going to get 5y equals root x plus 2. Subtracting 2 from both sides, I'm going to get 5y minus 2 is equal to root x. And then finally, to get x by itself, I'm going to square both sides. So what I'm going to end up with is 5y minus 2 all squared is equal to x, like that. Okay? So once you've got it rewritten, so you've got what x in terms of y, then g to the minus 1 of x, we're just going to take this part on the left here, and we're going to write it. That's going to be our answer, but we're going to replace back our y's with x's. So our answer is going to be 5x minus 2 all squared. Okay. And then part B says solve g of f is equal to 3. Okay. So f's on the inside, so that means we're going to take our f of x expression and we're going to write it where we see the x in g of x. Okay, so in other words, what I'm going to get is for gf of x, I'm going to get the root of, but rather than having the root of x, I'm going to have the root of f of x that I've got over there. So this part here, the 3x plus 4 is going to appear there under the root symbol. So I'm going to get the root of 3x plus 4 and plus the 2 divided by the 5, and then that is equal to 3. Okay, multiplying through by 5, I'm going to get the root of 3x plus 4 plus 2 is equal to 3 times 5 is 15. Subtracting 2 from both sides, I'm going to get the root of 3x plus 4 is equal to 13. Okay, then I can square both sides to get rid of that square root symbol on the left. So the square of root 3x plus 4 is just 3x plus 4. And the square of 13 is 169. Taking 4 away from both sides, 3x is equal to 165. And then finally dividing through everything by 3. 3's into 16 go 5 times, remainder 1. And then 3's into 15 go 5 times, so it's 55. X is 55. Question 21. A, B and D are points on the circle with centre O. CDE is a tangent to the circle at D. Work out the size of the angle ADC. Write down any circle theorems that you use. Okay, so first off, I just normally check that everything in the written part of the question is on the diagram. It appears to be the case. So work out the size of angle ADC. Where is ADC? ADC is ADC. We're talking about this angle here. Okay, so it's the angle between a tangent and a chord drawn at the point of contact. Okay, so generally, what do we know about these? Well, we've got like the alternate segment theorem, which says if you subtended a chord off there somewhere over here, look, then that then that angle up there, look, is going to be the same as ADC. Not sure if that helps us. Does that help us? Not initially. I don't see how that helps us. What else can we do here? Well, I guess if we draw an extra line in, so if I draw a line from O to A, there, look. Let's draw an extra line in. Then what have we got now? The reason I drew that is because I saw that if I do that, then this here is an isosceles triangle, AOB. So AOB here is an isosceles triangle. We know that because OA and OB are both radii, so they're both the same length. Okay, and so if we do that, then this angle here, look, is another base angle then of the isosceles triangle, must also be 51 degrees. And if that's true, then I can work out that angle there, okay, because that's just the third angle inside that triangle. So AOB, angle AOB, is going to be 180 minus the 2 lots of 51 degrees then, isn't it? The two other angles. So 2 lots of 51 is 102. Take that away from 102, that is 78 degrees. Okay? And then, so I know then that one there is 78. Okay? So now I've got angle AOD, look, this angle here is the angle at the center for this angle over here, which is at the circumference. So I've got that that circle theorem where you've got an angle at the center and an angle at the circumference. So that one there is double that one there, isn't it? Okay, so we can then use that one to find that angle up there that I created. So I created this extra angle up here. So if I call this point P, then I can say APD is going to be equal to half of angle AOD then, isn't it? The angle at the center is twice the angle at the circumference, so the angle at the circumference is half the angle at the center. So that's going to be half of 78 plus 64. So what's 78 plus 64? That's 82, 142, and then divided by 2, that's equal to 71 degrees. Okay. Now I used a circle theorem there to answer that part of the question, and it does say write down any circle theorems that you use. So I'm just going to write that down in brackets after what I did there, so I can say that angle at the center is twice angle at circumference. That's the rule I used there. Okay, so then I know that this angle over here is 71 degrees. Okay, and then because of the alternate segment theorem, then I know that this one down here must be 71 degrees as well, because that angle 71 is subtended off the same chord as joins onto the tangent down there then. So then I can say, so I'm going to write that down, so that angle ADC, okay, angle ADC, that is equal to APD, and that is the alternate segment theorem. Okay. Right, so the key to getting that right, well, I had to add some extra bits in, didn't I? So if you think about it, I put in the line OA to form that isosceles triangle, and I also put in the point P and made an angle subtended off that chord AD. Okay, so I added a couple of things into the diagram in order to help me solve it. So don't be afraid to do that. If you haven't got enough information, or haven't got enough lines and things on the diagram, you can always add a few more in and apply other circle theorems like I've done there. Okay, so the answer is, well, they were both equal to 71, weren't they? Okay, so that's my answer, 71 degrees. Question 22, ABCDEFGH is a cuboid. AF is 6.8 centimeters, FC is 13.6 centimeters. Work out the size of the angle between FC and the plane ABCD. Okay, so we just got the basic cuboid draw, and we haven't got these other lengths added in. So I'm going to do that first. I'm just going to add that information into the diagram. So I've got the line AF. Where's AF? AF is this line here. Look, that's AF. And I know that that length there is 6.8 centimeters. So I'm going to add that to the diagram. And FC. Now FC is, just going to use a ruler for this one because it's quite long and it's not been drawn on. That is the long diagonal that cuts all the way across from one corner to, that cuts all the way across from one corner to the opposite corner down there, look. And that one there is of length 13.6 degrees. Okay, now what we need to do is we need to work out the angle between FC and the plane ABCD. Well, the plane ABCD is the base of this shape, isn't it? So this is ABCD, this part here, this plane is just like a face or a two-dimensional part of your diagram. Okay, and so we want that angle between there and there. Okay, now probably in order to find it, it would probably be handy to know something else in this diagram. I'm thinking what we want to do is kind of make a triangle here from A to C. Can you see then I've got a right angle triangle? So add in that line in as well. Again, the same with the last question. Don't be afraid to add some extra bits into your diagram if you need them. So now I've got a right angle triangle ACF. Okay, can you see that? So it's got a right angle at A, and I know two of the sides there, so I'm looking pretty good, I think. So actually all I really need to do for this problem is a little bit of basic trigonometry. Okay, so what's the basic trigonometry? I hope it's going to end up as a nice angle because I don't have the calculator, remember. But so that angle there is equal to, let's call it theta. And then so AF is the opposite, it's opposite theta, isn't it? And FC is the hypotenuse of that triangle. Okay, so we've got the opposite and we've got the hypotenuse. So SOHCAHTOA, that means I've got the opposite and the hypotenuse. It means I don't have the adjacent, doesn't it? The adjacent is not required. So any of the ones with the adjacent in are not needed. So it's not going to be cat, it's not going to be TOA, it's going to be SOT, isn't it? It's going to be the sine. So the sine of my angle, sine theta, is equal to opposite over hypotenuse. Okay, and the opposite is 6.8 and the hypotenuse is 13.6. Have you noticed that 13.6 is twice 6.8? Okay, it's twice as big, isn't it? So if I divided top and bottom by 6.8, okay, then I'm going to get sine theta is equal to a half then, aren't I? So what angle has the sine theta equal to a half? I know that one already. I know it's 30 degrees, but if you didn't know it was 30 degrees, remember you've got like that table that we learnt earlier, or we went through earlier, 0, 30, 45, 60, 90 for sine and cos, all over 2. So you start with 0, 1, 2, 3, 4 in this direction, and 4, 3, 2, 1, 0 in this direction. So where are we going to get a half from? Well, sine of a half, it's going to be sine of this one, look, over 2. So sine of a half is equal to, it's going to be the 31 there, isn't it? That's where it comes from. I kind of just remembered that anyway. I know that sine 30 is a half, so I just spotted that straight away, that theta must be equal to 30. So theta is equal to 30, and that's my answer then. What's the angle between FC and the plane ABCD? It's 30. Question 3, write 3 root 3 over 4 minus root 3 minus 2 over root 3 in the form of a root 3 plus b all over c. Okay. Now, when I'm looking at this, the first thing that I notice is that we've got some surds in the denominator. So here I've got 4 minus root 3 there, and over here I've got another root 3, whereas the thing I'm trying to make it look like, that has just got an integer there. Okay, so the first thing we're going to have to do is rationalize the denominators of these two fractions. Okay, now I think what I'm going to do is I'm going to split it into two parts. I'm going to rationalize them first, and then I'm going to put them back together again then. Okay, so starting off with the first part of this expression, I've got 3 root 3 over 4 minus root 3. Now if I want to rationalize the denominator, what I need to do with these ones that look like this is I have to multiply top and bottom by the same expression, 4 minus root 3, 4 minus root 3, but what I need to do is I need to flip that sign in the middle. So if it's a minus in the original fraction, then the two values that you need are going to be positive. Okay, now the reason for that is that when you multiply them together, let's just put the numerator together and the denominator together. So doing FOIL on the denominator, I've got 4 times 4, which is equal to 16. And then I've got, if I then multiply the 4 by the root 3, that's going to give me positive 4 root 3. And then moving on to the second term, minus root 3 times 4, that is going to give me minus 4 root 3. And then finally I've got minus root 3 times root 3, that's going to give me, well, root 3 times root 3 is just 3, isn't it? So that's going to give me minus 3 on the end there. Okay? Now notice that the plus 4 root 3 and the minus 4 root 3 are the same term but opposite sides, so they're going to cancel out, which is kind of why we do this multiplying through by the complement. It's so that you end up with 4 squared, 16, minus root 3 squared, which is 3, and 16 minus 3 is 13, which is a rational denominator. So we have managed to rationalize the denominator. Okay, so we've got 13 on the bottom. Now what's happening on the numerator? I've got 3 root 3 times 4, that's just multiply the 3 and 4 together, that's going to give me 12 root 3. And then I've got 3 root 3 times root 3. Root 3 times root 3 is 3, times it by the other 3, that's 9. So I'm going to get 12 root 3 plus 9 on the top. Okay, and we said that's all over 13, so that's just 12 root 3 plus 9 all over 13. Okay, now the other part is a lot easier. 2 root 3, 2 root 3. If I want to rationalize that, I just need to multiply top and bottom by root 3 over 3, the same denominator on and with the same numerator as well, because root 3 over root 3 is just 1, so multiplying through by 1 won't change it, but it will change the form because root 3 times root 3 is 3 on the bottom, and on the top I'm going to get 2 root 3. Okay, so I've rationalized both parts of that algebraic, those algebraic fractions, so now I'm going to bring them back together again. Okay, so this part here, look, this bit I've rearranged to make this, so bringing that back together and putting the two pieces together, then I've got 12 root 3 plus 9 over 13. Okay, and then the second piece of the puzzle was this one, I've rationalised that to that. So I'm going to subtract 2 root 3 over 3 for that one there. Okay? So now I've just got two fractions. The denominators are not equal. I need to find a common denominator here. So what's common out of 13 and 3? Well, they're both prime, so they don't have any common factors. The simplest common denominator is going to be the two numbers multiplied together, isn't it? It's going to be 39 on the bottom. So 13 goes into 39 3 times, so I'm going to have to multiply everything on the top of that fraction by 3. So that's 12 root 3, lots of 12 root 3 plus 9, minus, and then 3 goes into 39 13 times. I'm going to have to multiply the numerator of the second fraction by 13. Okay? So then, let's just tidy that up then. 3 times 12 root 3, that's 36 root 3. 36 root 3. 3 times 9, 9, 18, 27. Minus 13 times 2 root 3. Well, 13 times 2 is 26. So that's 26 root 3 there. And that's all over 39. Okay? Almost done. Just one final step. I've got two terms in root 3, 36 root 3 and minus 26 root 3. So taking one away from the other, 36 minus 26 is just 10. So that leaves me with 10 root 3 plus 27 all over 39. And that's my final answer, isn't it? 10 root 3 plus 27 all over 39. That's my final answer. Good. Question 24. Find the set of possible values of x for which 4x squared minus 25 is less than 0 and 12 minus 5x minus 3x squared is greater than 0. So we've got some quadratic inequalities here. My advice is to factorize them and try and sketch them and see what they look like, and because we've got two, it's quite a complicated business here. Now that first quadratic, 4x squared minus 25, I recognize straight away. It's the difference of two squares. You've got a squared minus b squared, where a is 2x and b is 5. So that factorizes to 2x plus 5, 2x minus 5, and that's less than 0. Okay, so then if that's true, then what are my roots? So I'm going to have roots then at minus 5 over 2 and 5 over 2 from those, aren't I? Okay, so if I was going to sketch that, I would have a smiley looking parabola because I've got a positive x squared term like this. Okay, and then one of those values would be going through minus 5 over 2 at the axes, and the other one would be going there, crossing it 5 over 2. Okay, so we're interested where it's less than 0. So that's true between those, isn't it? It's going to be less than 0 where it's below the x-axis. So at the moment, we're talking about that section there. So that bit there, with x values between here and here, is where the 4x squared minus 2x is minus 25 is negative. But we've got the other one to add on as well yet. So we've also got 12 minus 5x minus 3x squared greater than 0. Now before I start factorizing, I don't really like the fact that this has got like a minus 3x squared term. It makes it a little bit harder to factorize. So I think I'm going to flip it round and move everything to the other side. So rather than having 12 minus 5x minus 3x squared is greater than 0, I'm going to move everything over the inequality symbol and do it the other way around. So I get 3x squared plus 5x minus 12 is less than 0, if you think about it. So I've left the inequality in 0 around the other way, but I could just shimmy that over to the other side and write it that way around. Okay, that's going to be a whole lot easier to factorize. So 3x squared at the beginning, so I'm going to have a 3x and an x, and I've got a minus 12 at the end there, minus 12. Factor pairs of minus 12 are 1 and 12, 2 and 6, 3 and 4. Now which pair is going to deliver me 5x in the middle? Remember, the one I put here is going to get multiplied by the 3x. So, and one's positive and one's negative. I'm thinking the 3 and the 4. If I put the 3 here, that's going to give me 9x. So if I put the 4 there, that's going to give me 4x, and I can make 5x out of 9x and 4x, can't I? So if I make this one positive, that's going to give me positive 9x, and if I make this one negative, I'm going to get minus 4x. And when I combine them together, that's going to give me the 5x in the middle, isn't it? So I've got 3x minus 4 and x plus 3 is all less than 0. So that means that the roots here are going to be x is 4/3. And my second root is going to be minus 3 there, isn't it? So, okay, so on this diagram, let me just put the y-axis in for reference. So y-axis is there, look. So my first limit of minus 3, that's the one on the left, isn't it? That's going to be to the left of 5 over 2. 5 over 2 is minus 2.5. So I'm going to have another point there at minus 3. That's the root of the second quadratic. And the upper root of it, 4/3, that's going to be slightly to the left of 5 over 2. 5 over 2 is 2.5 versus 1 1/3, which is going to be here, isn't it? So that's my 4/3 or 1.5, 1 1/3 there. So my second parabola kind of comes down and then goes back up like that. Okay, now we're interested in the range of values that satisfy both. Okay, now obviously, you know, from minus 3 up to 4/3 satisfies the second quadratic, and minus 5 over 2 up to 5 over 2 satisfies the first quadratic, but these ones in the middle satisfy both. They're the values that both graphs are below the axes. Okay, so we want that range between that limit there, the minus 5 over 2, and that limit there, the 4/3. So we're going to say then our x value needs to be bigger than minus 5 over 2, but smaller than 4/3. Okay, because it needs to satisfy both. It's and of those, so it needs to satisfy both. Okay, a little bit tricky, that one. Need a sketch really to kind of suss it out, so don't skimp on your sketches.
You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.